I'm Dalton Hubble. I'm an engineer here at CoreOS. I've spent about the last year and a half working on the Tectonic team, which Rob just talked about. We did a big release. I worked on the bare metal and AWS Tectonic pieces, and I'm sort of switching gears now to work on a bunch of container Linux stuff and explore some different areas. This talk has nothing to do with any of that, actually. This is sort of a lightning talk of a random hack that I did a couple months ago, which I dusted off and scrubbed the rust off of to show. Some of it's pretty weird and crazy, so hopefully, yeah, take it with a grain of salt. I'm trying out a new slide deck tool. So this is about as big as it's going to get. So if you if you want to see stuff, scoot forward. If you want to stay at a safe distance, continue to stay where you are. So I'm going to talk a little bit about some experiments that I've done with QEMU and KVM in a Kubernetes cluster, especially on bare metal Kubernetes clusters. So just to review a little bit, QEMU is a machine virtualizer emulator. You can emulate almost anything with QEMU, and when you combine it with KVM, you get almost native performance. KVM stands for kernel-based virtual machines. It's both a feature in the kernel and also a kernel module. It exposes the dev KVM device file interface that allows user space programs to actually take advantage of CPU virtualization features. So when you combine those two, you can launch VMs sort of natively in Linux. There are two main places that I use QEMU KVM. I'm by no means an expert, but there are two places I use it all the time, and maybe you do too. The first place is for container Linux. There are a bunch of docs on how to launch container Linux instances under QEMU and KVM. You've probably seen those docs, but if not, they're linked right here. Usually you do this from like a server or your laptop to play around with container Linux. The other place we use it a lot is CoreOS Matchbox. This is an on-premise project that I developed that actually powers a lot of Tectonic, and it's a piece of software you run on a network, and when machines PXE boot, it matches them with specific profiles to provision an entire cluster automatically. And the actual test environment for that, our Jenkins CI environment, tests that by having a small virtual bridge, running Matchbox on it, which is the thing under test. Whoa, it's a lot louder. The thing under test, and then launching a couple QEMU KVM VMs and just waiting for them to provision themselves into a cluster. And if they come up as a cluster, that's a success. And if they don't, that's a failure. So these are the two places that I had mostly used QEMU KVM before. The thing is, once you actually set up a bare metal Kubernetes cluster, that's the end product. It's pretty tempting to want to run VMs on there too, because why have a special cluster to run all your VMs when you have this perfectly nice bare metal Kubernetes cluster? So that's when I started experimenting with some of this stuff. And a lot of this is that's basically all the preamble. The rest of this talk is mostly demo. Let's see here. So we have ourselves a bare metal Kubernetes cluster sitting here. This is at a co-location running nearby. So let's hop into the right directory here. Very first part, I'm going to launch an Alpine deployment, just a simple Alpine container. The only thing that makes it unique is that I've set the security context to be privileged true. For those who are familiar, privileged containers basically maps directly to Docker's -- privilege mode. It is a feature that they introduced to basically allow you to do Docker within Docker. It means the container can access the host's device files, along with a couple of other things. So let's go ahead and do. What happened here? I ruined everything. Sorry, I might have nuked my deck. That's okay. Okay, so we have an Alpine pod running. I'm going to exec inside. And just immediately, we see that there's a dev KVM is available. So let me fix whatever horrible thing happened up here. Sorry about that. So the dev KVM is available inside of this container because I launched it as a privileged container. So let's actually just go ahead and follow the CoreOS docs. This is the abbreviated version of them. And we're going to install QMU system x86, bzip, and wget really quick. And we're going to download a container Linux image. Should only take a moment. And we're going to decompress it. It downloads pretty fast, really. 300 megs. So it's packaged as a bzip2, and we'd like to get the raw image format out. That'll take a moment. Oops. And the last part is, this is the simplest possible QEMU KVM instance invocation that I could find. It's basically saying, launch a QEMU KVM instance, enable KVM specifically, provide it with 1 gig of RAM, and use the the container Linux QEMU image as the disk, and launch it in no graphical mode. So this is all being done from within my Alpine container on my bare metal Kubernetes cluster. This is sort of to illustrate the idea that there's nothing preventing me from launching a QEMU KVM instance. It's exactly as if I had done it on the host, really. You can do it from a Linux host, you can do it from within an Alpine container that's privileged. And here I get a container Linux inside of a pod. And in this case, I haven't actually provided any kernel flags or cloud configs or ignition files, any sort of configuration to allow myself to get into this machine, so this is mostly as far as I could go for this demo. This is just illustrating the concept of I can launch this VM. So let's hop back to the slide deck. So let's say I didn't want to do all that manually. You can actually sort of package this up into a nice container. What kind of things do I want that container to do? So at the build phase, I just want some sort of host pod, host container that has QEMU installed. You can run almost anything with QEMU. Add some tools, whatever you need, inside of your pod, and you're ready. There are a couple tricks to getting this to work, and I'll lead up to showing an image that actually does this. The first is QEMU has an option called host forward. This allows you to take a local port, like 2222 on the host, which in this case the host is that Alpine pod that I was talking about, and it'll do a local port forward to port 22 of the guest. So that means if I was inside of that pod, I could SSH on port 22 to localhost. It's just a feature that's built into QEMU. This will turn out to be super useful because you probably want to have networking to your VM. Otherwise, why even launch it? The next tip that I figured out was, actually that's a different one. This is container Linux configs. So container Linux supports the container Linux config file format. It's a way that you can specify really what you want your machine to do. If you've heard of Cloud Init or Cloud Configs, it's very similar to that. It allows you to write a YAML file which completely declares everything that your machine should do, from creating partitions to writing a bunch of files, writing systemd units, writing networkd units, regular files, adding users, adding SSH keys, stuff like that. And that YAML file is behind the scenes sort of converted into an ignition file. Right now you have to do it yourself. There's a little tool that allows you to do it. That may someday be baked into container Linux. We're not sure yet. But it's effectively a YAML file which allows you to declare whatever you want that machine to do. So for example, are these big enough? Okay. This is a very, very minimal container Linux config. It's saying basically for the user core, which is the default user on container Linux, add this SSH public key so that I can get in. Or you could do something more advanced, like when this instance starts, please run an etcd2 service with all these environment files. And this is just systemd launching it. So you can use container Linux to specify that your container Linux VM should do virtually anything that you want it to do. How do you get that config into the VM? It turns out QEMU has a feature for this too. It's called the firmware config drive, FW_CFG. So the trick is, if you provide a container Linux config and use this little tool called CT, the config transpiler, it spits out the machine version of Ignition, the machine representation, which is an Ignition config. And then you can just sort of pass that file from the host, which again is the pod, into the guest, which is the container Linux instance, just using this firmware config pass-through option. So these are sort of the nuts and bolts and tools you need to construct an image which will launch a usable container Linux VM for you. Fortunately, I've gone through that for you. I have nightly Jenkins pipelines which publish this for fun. Can I click on that? I can click on that. So, sorry, I'm still discovering this slide tool. So yeah, there's a public CoreOS KVM instance. It goes and hunts down the latest 3 container Linux images, and it builds those into a Docker image. They're pretty massive at the moment, and they're based on Ubuntu, which is why all these vulnerabilities are here. And this has some of the niceties that I will mention over here. So it's just a bunch of bash scripts inside if you take a look. It takes a config file, which is a container Linux config file. You can pass in a raw Ignition config, or you can pass in a cloud config. So that's 3 options. And then it takes some very, very basic environment variables that really just get passed through to QEMU. It's like, what should the name of the VM be? How much memory should it have? How big should the disk be? And then what ports to actually forward. So this is where we switch over to do a little demo. Where am I? We'll take a look at these in just a moment. Let me create these. So I'm creating a config map, a deployment, and a service that are actually using this CoreOS KVM image that I publish. Let's first take a look at the deployment. So, like I said, CoreIO, DG Hubble, CoreOS KVM. Security context is privileged, and I'm setting the amount of memory and the disk size that I want my VM to have. And then I'm mounting in a config map as a volume, and then just passing it with this environment variable. And that'll get passed inside, that'll get passed with the firmware config drive pass-through. Let's take a look at the config map. It's really simple. It's very simple, similar to the example I just showed, where there's a file called, this is a regular Kubernetes config map. There's a file called config.yaml. And all it's doing, this is the most minimal container Linux config ever, is saying, for the user core, add Dalton's SSH key as a pub key. Nothing else. We're not setting up any services or doing anything fancy. And then the final bit is the service file, which is saying, I'll have a diagram where we talk about this, but expose port 222 as port 22. So let's see if that pod's running. It is. We can see that this CoreOS KVM instance has a particular cluster IP. And here's the cool part. I can SSH into that because it's exposing port 22. I have a YubiKey, so. And yeah, we're in container. We just SSH'd into a cluster, a pod's service IP, and now we're inside of container Linux, or it thinks we are. So that's the first piece. We're now able to launch a config map, a deployment, and a service, and effectively SSH into a VM. Did I have anything else to say about that? Oh, I do. I have a diagram to show how that network piece works. So if you're wondering exactly how I SSH'd into that, I sort of broke it down into this beautiful ASCII diagram here. So this is the pod right here. It is running CoreOS KVM as the host. It is doing local port forwarding from 2222 into the guest on 22. So basically the pod is exposing 22. And the Kubernetes endpoints all the pod endpoints are exposing 22, and I have the Kubernetes service abstraction in front of that, which says expose the pod's 2222 port as 22. So it looks like I'm just SSHing into a regular service, and it's a VM. That's how you achieve that behavior. So I think everything up until now has real applications, if you're interested in like setting up a Jenkins cluster that has like ephemeral CoreOS instance executors, and you want to do Docker builds or Docker pushes, or you need a VM for any other purpose, or you need to run Windows VMs or like random stuff like this, this is a way you could do that. I'm not saying it's the best way. It's kind of a weird way to do it. Everything going forward is definitely in the weird category, because we're now going to take that VM and try to make a single node Kubernetes cluster out of it. Not because it's like a good idea, just because we can. So the steps involved are sort of the same as before. Is we want to write a Kubernetes deployment, a config map, and a service. And that deployment just needs to launch a container Linux VM. That config map needs to specify everything needed to set up a single node Kubernetes cluster. Fortunately, the Matchbox project has all sorts of examples of container Linux configs that do different things. They set up etcd clusters, they set up Kubernetes clusters. We're just going to copy one of those. And then we need to set up a Kubernetes service to expose both port 22, which you saw before, and also 443, so that I can use kubectl to talk to my nested Kubernetes. And we need a DNS record so that kubectl will work. So for this last part, I'm going to run the commands, and then we're going to talk about what it does, because it takes a few minutes for this cluster to set up. So it's similar to before's. I'm just if I could spell, kubectl, create a config map, create a deployment, create a service, ooh, that was scary. Stuff is happening. It'll take, even though the pod has started, that pod has to now go launch a VM, and then the VM has to download all the hyperkube images, start a bunch of services, and become a Kubernetes cluster. So we're going to give it a little bit of time and talk about what we did. The first part was the deployment. This is just using all the tricks that I just talked about, but I'm going to break it down. First, it's using the image is the CoreOS KVM image, which we've painstakingly built. It happens to be Container Linux stable 1353. We're using this random argument, which gets passed directly through to QEMU and says, when you run this pod, forward local port forward, port 2222 to the guest's port 22, because we're exposing SSH if we need to get in and debug stuff. And we're exposing 1443 local port forwarded to the Kubernetes API server inside of the VM, which is on 443. And you can see that specified right here. And the final part is we're mounting in a config map, which I'll get to, I think, next. And that config map will tell the machine what to do. Oh, nope, we're going to talk about the service first. So the service is just remapping those back to 22 and 443. And I've set the cluster IP to some known IP so that I can have a DNS record. This is sort of a nicety so that the demo works, is that I need a DNS record that I can mint TLS certificates for, so that's why I've pinned this cluster IP to a specific value. The final part is adding that DNS record, minting a bunch of certs, and putting them in the Container Linux config map. We're not going to look at any of that. Basically, the Container Linux config map is going to start etcd, start flannel, start kubelet, have all the Kubernetes control plane manifests. These are all just files that get provisioned inside the VM. And I think I can briefly scroll through. I don't know what's happening. I don't know why it thinks that's the top of the file. Well, you can see that there's etcd, there's a flannel service that gets created, locksmith, kubelet unit is set up. This is a 152 cluster because I haven't updated it. I'm embedding all the certificates directly in the Container Linux config. You should probably mount these as secrets, but this is just a hack. What else? Okay, then we get into the etc Kubernetes manifest folder that has all sorts of manifests for stuff. So if you're interested in the contents of this file, it is literally just copied from Matchbox. But let's actually see if it works. I really hope it works. OK, so I minted those TLS certificates, and I happen to have the kube config that corresponds to that right here. and it points to nestedk8s.lab.dghubble.io. If I dig that, oops. I'm showing this so that you're clear that I'm not pulling the wool over your eyes. This actually maps to the Kubernetes service IP. So if I list nodes, this is the top-level bare metal Kubernetes cluster, which is running these pods, the Alpine one, the Container Linux pod, and the Container Linux pod, which has a whole Kubernetes cluster inside of it. And now, if all goes well, I can specify I'm now talking to the Kubernetes cluster inside of the Container Linux VM, which is inside of the pod. And it's a single node, yeah. And, and you can see it's running things. And you can tell that it's different from the other one because the top level cluster is 11 days old, and this one that I just launched is like 1 minute old or 21 seconds old. And I was going to show the Kubernetes dashboard, but kubeproxy is not working in this weirdo janky setup. So sorry about that. So that's nested Kubernetes. Yeah, there are improvements to be made. And the final bit I wanted to touch on was sort of back to reality. Is the VM stuff has a lot of real-world applications, especially for ephemeral machines. But you can also build an image which, like, you mount Ceph volumes into the pod, and then you mount them into the guest VM. You could go really, really crazy with it if you wanted to. That stuff actually has useful applications. I use it for like my Jenkins cluster to do useful work. The nested Kubernetes is sort of a party trick, but it does have a few applications that I was able to come up with. It's like if you were a person who develops on federated Kubernetes, this might be a fun way to like deploy a ton of Kubernetes clusters and do some testing. Or another person a long time ago asked me, like, they said that they wanted to run one Kubernetes cluster that the operations team managed, and they wanted to give each developer their own little kube config to an isolated Kubernetes cluster, and they didn't trust their developers to be able to set up a Kubernetes cluster on their laptop. So I guess this would be one way to do it. I do want to provide a huge, give this to you with a grain of salt, because the design here is lacking in a lot of ways. So this is basically running a VM in the pod by executing QEMU system x86 directly. It's sort of baked in the image. In fact, the image is doing all the work. It's the image. I've added environment variables which accept like how much memory, how much disk. It'll set up those configs. If you wanted to do like snapshots or migrations, you'd have to put that in the image too. It's a pro because you can do anything you want. You don't have to ask permission from anyone. You don't have to contribute code upstream or get it merged or like beg anyone for approval. You can do anything you want now on a regular bare metal Kubernetes cluster. You don't need add-ons or anything. That's also a huge con. Is like Kubernetes is completely unaware of the fact that I'm running VMs inside of it or that I'm running a nested Kubernetes cluster inside of it. So I don't want anybody to like take away the message is like, CoreOS says to go do this thing, or Dalton says to go do this thing. This is just a fun hack. And some of the more mature things I see coming up is, so Rocket has this ability to swap the stage one, which means a Rocket NetEase cluster will typically launch containers, but you can also swap in a stage one so that it will go launch KVM instances. So that's a promising idea for the future. And the other project I saw from some Red Hat folks is called KubeVert. And it's sort of an idea that you can make the Kubernetes cluster aware of VMs by sort of bolting on these add-ons, so that it's sort of an operator and a bunch of add-ons that run like a libvirt service that you then talk to through Kubernetes third-party resources. And I can't say that I really recommend that yet. I haven't really tried it, and it seems a little bit new. But that does seem like maybe the more mature way to go. Like in the future, I imagine we'll see something like that, where Kubernetes has some sort of thing bolted onto it so that it becomes VM aware. We're able to talk to the scheduler is aware of VMs, something more mature than what's being done here. But that shouldn't stop you from hacking around on it and seeing what you can do. And hopefully you've enjoyed this. And now you can run nested Kubernetes if you really want to. Yeah, that's all I've got.